is the first in a smaller series of SEFI at Work webinars that is generously sort of our home, that the host is with the Ethics SIG, the special interest group from SEFI. And the series is uncertainty and discomfort, of looking at the different types of uncertainty that engineering students do encounter or should encounter, the types of uncertainty that students and professionals should be able to manage and work within, and the different educational strategies that we use to generate opportunities to encounter that types of discomfort and to develop effective strategies for dealing with that. So we'll be having about one webinar a month for the next 6 months in this sort of phase of the series. So today, specifically, the goals of this particular workshop of having you here with us today is that our invited speakers here today, Elliot Douglas and David Therriault, will talk to you about what makes engineering problems ambiguous, about how to incorporate more ambiguity into the types of assignments that you're giving to your students. And since we're all here temporarily together, to connect with each other about what we're doing around uncertainty and ambiguity, and what we could be doing, and what we think is important, and what are the questions that we're still having. So we're actually going to start with that piece of that third piece there in terms of connecting with others around their questions here. And I'm going to invite you to do what I've heard called a waterfall. So if you open up the chat app here in Teams, so the chat icon is pretty much up at the center of your screen above the picture of the little people, the little chat icon, and you can answer these two questions. If you type number 1 and answer the first question for yourself, and question 2 in the same chat bubble. So don't hit enter yet. I'm going to give you 3 or 4 minutes to think about these questions for yourself, and hang on to them. You can keep thinking about them, and then we'll all let them go at the same time and be able to catch up a little bit with what other people are thinking about or interested in or working on. So I'm going to be quiet here now to give you a chance to actually work on that in the chat. All right, so I'm going to invite you now to share your responses in either the Q&A or the chat, wherever they have ended up.
What? You are. Yeah. Let me know if you can join.
Excellent. This is really interesting to see lots of different types of uncertainty that has to do with what the problem is, what the approach to the problem is, about who they're working with, about the context that it's going to get implemented in. So really lovely to see that diversity in different approaches. And I'm looking forward to, through this series of exploring a number of those different types of uncertainty in the different talks. So I'm very pleased for today to introduce Elliot Douglas and David Therriault, who will be speaking specifically today about ambiguity in engineering problem solving. Oh, and I've hidden my notes for myself here. Oh goodness, I've really managed to hide my notes for myself with my multiple screens here. Yeah, I'm not allowed to do that. Why not? Well, I have hidden my biography notes for myself with the marvels of Teams. Why am I not allowed to see this? Yeah, I just get an error message when I try and see that. So I will tell you that they are both from the University of Florida. Elliot Douglas is in an engineering department, I think, environmental engineering?
Yes, environmental engineering.
And David Therriault is from the School of Social Sciences. I'm trying to remember this. Your background is cognitive psychology.
Yeah, I'm in the College of Education at the University of Florida.
In the College of Education. So a really lovely engineering education combination there with really different for each of you disciplinary backgrounds and perhaps sort of disciplinary research methods with a really lovely crossover here in terms of looking at how engineering students are thinking about engineering problems and how they're managing the ambiguity between perhaps what looks like really absolute black and white numbers written on a page and the complexity of communicating with other people around that and what that actually looks like in practice. So I'm going to invite you to, during the conversation, if you've got questions, to put them in the chat during the presentation, because since we have two speakers, they'll be able to have an opportunity to take a look at that. And at the conclusion of their presentation, which will be about 20 minutes long, then we'll have an opportunity for them to respond to some of those questions, and then an opportunity again for a sort of a broader discussion about thinking about what they've presented and about how you bring that into your work and into what's relevant for you. So I'm going to stop sharing here. Oh, that stopped sharing. There we go. And hand over to our guests.
Okay. First off, from Elliot and I, I'd like to thank the SEFI Ethics SIG for creating this forum, and specifically thank Sierra and staff for setting this up. I know Elliot and I talking about this are excited to kind of be in the discussion and be talking about these things. Incidentally, Elliot and I looked back on my Vita. We've been working together since 2008 on different grants and work in this area. So we like each other, or he lies really well. But it's been really a fun collaboration to see interdisciplinary sort of work and where it ends up. By way of introduction, as she mentioned, my name is David Therriault. I'm a cognitive psychologist. I was trained in sort of studying memory, attention, problem solving, and I kind of identify as a cognitive scientist. I do work in engineering, chemistry, medicine sometimes, also straight up in cognitive psychology. So go ahead, next slide, I guess. Thank you, Elliot. There we go. So today is a preview. We're going to kind of walk through in broad strokes. I'm cutting my time to like 8 minutes or less if possible, because I think the discussion, I'm more excited about reading the comments here than I am presenting at this point. We'll talk about our trajectory in research exploring problem solving and engineering, sort of the role of ambiguity, and unveiling our approach of a categorization of uncertainty and ambiguity that we think is going to be useful, or we hope will be useful for folks in thinking about their teaching and thinking about research. So our research agenda is to define ambiguity, find the conceptual boundaries. We're trying to develop an instrument now, understand the different factors that may be affecting ambiguity, and then develop essentially trainings around this that can help students and that we can help to transition students to practicing engineers. Next slide, please. So on this slide, there's two observations I'd like to make very briefly. Is if you look at the top right-hand corner, this is sort of the monikers that are used to talk about problem factors, external problem factors. And if you look at these, a lot of the case, it is endogenous to a problem. Uncertainty and all of these things are things that are essentially part of the problem space. And that in some ways, it underestimates the role of the problem solver, the experience the problem solver has in this space. And that's one of the things we're trying to sort of highlight here, is that problems may or may not be ambiguous as a function of the people that are dealing with those sorts of problems, right? Now, on the bottom, what you see here is Jonason's sort of design theory taxonomy, and you may be familiar with it. There are 11 categories. The first is logic questions. Then the next is algorithmic problems, and it goes all through to stories. What are some of the other ones? Rule using, decision making, troubleshooting, diagnosis solutions, and then you head towards design at the very end, dilemmas. And this is a taxonomy, meaning it builds upon itself. So you fundamentally must learn how to do algorithmic problems before you can attend to things like design problems. That was part of his approach. One of the things we noted about this is the disconnect between, and this is some of our prior work earlier in the 2010, 2012 in that area, where we found that students were basically identifying with academic problems that were basically algorithmic, that had a single solution, and this is how they were thought they were trained, and that workplace problems didn't have this sort of like one solution answer, and it was more complicated, it had more uncertainty, more ambiguity, and so the gulf between these two make it very difficult then for us to say we're doing the training in a way that's going to help people transition from instructional engineering to basically practicing engineering. Next slide, please. So on the end of the spectrum where we talk about instructional approaches to engineering, this is your typical algorithmic problem that comes from a statics textbook. It is essentially you have to determine the moment of inertia on the frustum of this cone where it has this conical depression. This is one that's well scripted. It's well scoped. It doesn't contain much in the way of ambiguity. It has a single correct answer. And incidentally, we have a paper, I didn't tell you this, Elliot, we got the email yesterday, a paper that's accepted in a Journal of European Engineering, Education
European
Engineering.
Journal of Engineering. European Journal of Engineering Education.
There's so many acronyms, I have to keep track. So we looked at two statics textbooks. It was over 3,387 questions. We had an REU grant to look at this, and we found out that 98.9 of those questions were either logic or algorithmic problems. And of the solutions, it was either a single number or a formula 92% of the time. Okay, so if we just take statics as an example, we know that the training for that, if they're just using, textbooks and problems from the textbooks, which they may not, that basically falls on that taxonomy on the far left. Okay, next slide, please. Here, I'll give you guys just a moment to read this. This is a design problem.
And Gainesville
Okay.
is the city we are. Gainesville is the city we are in.
Yes, this is actually a real place.
Yes.
Yes, this is a real design problem, and also often in the news. So here we have one where it's ill-structured, it's not well scoped, it introduces uncertainty, and there could be multiple elements of ambiguity with respect to how one can approach this particular problem. Okay, next slide, please. So one of the things we focused in our work is essentially ambiguity, uncertainty in the problem-solving process. And in order to get like a handle on that, I think it's important to review its place in the psychological literature, and this is why I'm here. And in terms of ambiguity, it comes from three sources: personality psychology, reading comprehension or discourse processes, and then problem solving. Okay, in the area of personality is probably first used in the late 1940s, and there was something referred to as the tolerance for ambiguity, which was a proxy used to assess people's authoritarianism. Incidentally, that work has continued. There's no less than 6 or 7 different scales that measure tolerance to ambiguity. They don't tend to have a lot of psychometric validity, and there's a lot of work still being going on in that area. The next area is the area of basically discourse processes, where people are looking at how people differentiate or disambiguate words. So is it the bank, a financial institution, or the bank of a river? How do folks do that? This is like Sweeney's work and Duffy's work. This was work that was in the 70s and 80s. Essentially what they were able to discern is that people activate both meanings of the word bank and then quickly select the one which is built from the context of the rest of the sentence. Okay. Now the last one, which is the one that's going to be the most relevant for us, is in problem solving. But interestingly, when Simon and others started laying out their descriptions of problem solving, they did not include, they talk about ambiguity, but they did not include any sort of definition of ambiguity. Right? So everybody sort of sees it, says it's important, but we don't really know what it is. Okay. So next slide, please. Oh, go back. I'm sorry. So leave right there. That's fine. So hold on one second. Get my notes together. So ambiguity has been remains largely undefined, even though it's a key aspect of us understanding successfully solving engineering problems. The lack of the clear definition hampers our efforts to better understand approaches to ill-structured problems. Here we have two examples of definitions of ambiguity that we've been able to discern from literature. On the left is Shader, Riggs, and Smith's work, and this is one of the only ones that makes a distinction between ambiguity and uncertainty, right? Where uncertainty is essentially not knowing uncertainty is a lack of information, whereas ambiguity is a lack of understanding of the relationships between things. Okay, so you can have something that's high in uncertainty and low in ambiguity and vice versa. Okay, and then the other quote here, taken on the right, is the idea that ambiguity is essentially solving a problem, right? A precise and predictable formula for generating a product. This fits with some definitions. For instance, when we did a Think Aloud protocol with students, one of the students said, well, basically, if you have the right equations, then you can solve anything, right? So we're left with essentially knowing that ambiguity, solving uncertainty in engineering is critical, but it's not well defined. And so we sat and kind of thought about this, and we created sort of a research plan to begin to look at what could be categories of ambiguity, so we could study those and begin to discern which ones were more important than others, which were critical for pedagogical reasons, and things along those lines. And I will now turn it over to Elliot.
Yeah, and so like as David said, one of the ways that people, to paraphrase a Supreme Court justice in the U.S. from the early 1900s, sort of the way people mostly talk about ambiguity or define it is, I can't define it, but I know it when I see it. And we wanted to move past that and try to understand what it is. So we created this project to try to understand how do both engineering students and professionals describe ambiguity when they are doing engineering problems, right? So we interviewed professionals and students in civil and environmental engineering. We picked that. We know, or we suspect that our findings could be disciplinary dependent. We don't know for sure, but for now we're focusing on this single discipline. And I want to point out, we use we call artifact elicitation interviews. So what we did was we asked them to send us ahead of time problems that they felt were ambiguous. And those were used as the starting point for discussions. We find that this approach, by having something concrete, it makes the interviews much more productive rather than asking them to start off by defining ambiguity and then they don't know what it is. So this gets us into much more concrete discussions about what makes a problem ambiguous or not. And then we did standard coding, constant comparison to develop themes and sub-themes around it. We're not going to delve too deeply into the sub-themes just for time's sake, but I'm going to show you, here's our results. So at the center for both students and professionals, we find technical ambiguity. And where's my notes? I need to find my notes. So technical ambiguity is the application of science, technology, engineering, and math principles, as well as the calculations and procedures needed to solve problems. That's how we're defining it. So all the things you think about when you think about the calculations and things like that with ambiguity. There are some differences in the sub-themes. I'm not going to go into great detail between those, although you'll see an example in a little bit. So that's the center. Without that technical piece, we don't have an engineering problem. But surrounding it are other aspects of ambiguity that also feed into the problem depending on the nature of the problem. So we have discourse ambiguity. This refers to the use of language, both verbal and written, and it has to do with the way the components of a problem or project are described or communicated. We have interpersonal. This occurs in the interactions between people working on a problem. So it's different from discourse because of course there's language in that communication. It's different because this focuses on the relationships between people and how they interact, not just the language. And of course, in discourse, language doesn't have to be between people. For example, professionals talked about contracts and the ambiguity in contracts. Intrapersonal, this one's important because it really highlights what David said at the very beginning, which is that ambiguity, as we find, is not just about the problem, it's about the problem solver as well. And so this comes from the personal characteristics of the problem solver. For example, experience and knowledge. So people talked about how problems that might be ambiguous earlier in your career are not ambiguous later in your career. Okay. Non-technical is the project elements that are unrelated to math, science, or engineering. So these are things like professional skills. So ethics, for example, was one. Interestingly, I'll point out that only one of our 14 professionals talked about ethics at all. Whereas for students, this was the most mentioned topic within the non-technical area. Professionals talked about the financial piece of it as well, so costs and how that might play in. And then there was this interesting one from students, instructional ambiguity, that's related to the way instructors taught the class and interacted with students. And one really interesting one that they brought up was what we call intentional ambiguity, where they felt that instructors were artificially creating ambiguity just to have it in the problem. Some students said it's to trick us. Some students said it from a positive standpoint and said it's so we can get used to the kinds of problems we're going to see in the workplace. One of the big differences between students and professionals with regard to ambiguity was that professionals tended to see ambiguity as a natural component of engineering problems. It's just something that's there and it's something you have to deal with. Whereas students saw ambiguity as an obstacle that needed to be overcome. So a very different mindset in terms of how they approached ambiguity between those two. And like I said, we have a lot of things in the sub-themes. I'm going to skip those over in the interest of time. As David said, I'm really curious to hear the discussions. So that was one of our major things, the difference in mindset between the students. But the other really important one, again, it ties into this idea, we call it ambiguity as experience. And so here's an example of 3 quotes from 3 different people, 2 professionals and 1 student. And we pulled this out. This has to do with information, to the extent to which a lack of information makes a problem ambiguous. So this professional said, and you can read the whole quote, I'll give you a moment if you want to, but I've highlighted in red the important piece. And this professional is saying that just because you don't have information doesn't mean the problem is ambiguous. You have to get more information to solve the problem, but the problem itself is not ambiguous. You know how to do it. You know what needs to be done. Now, if you look at this second one, this professional, and they're not necessarily talking about the same problem. I want to make that clear. So this professional says, what makes this problem a problem ambiguous is when all the information isn't there to make a decision. So in this case, there's a lack of information, but it's not necessarily the lack of information itself that makes the problem ambiguous. It's what that means for the problem that you can't make a decision. Whereas the student very specifically said, and I saw this in one of the chat comments, I believe there was a comment about lack of information as a difficulty for students. This student says there's not enough information out there, and they're looking for it to be funneled into a single answer. And so for the student, this lack of information is what makes the problem ambiguous. So we see that the different ways that these people look at a problem, changes whether or not they think it's ambiguous. So this is my last slide, just to say, let's look at this problem. Okay, this was actually one of the problems that the students gave to us as saying it's ambiguous. Okay, and they have to estimate water runoff as a function of land use change. So the question is this an ambiguous problem? And the answer from our perspective is, it depends. We don't know. It depends on the problem solver. So one of our big findings is that it's not, ambiguity is not inherent in a problem. It's inherent in the problem solver's interaction with the problem. And of course, that makes it much more difficult to say, how am I going to design a problem that's ambiguous? But I think it'd be interesting to hear the discussion. Our idea, and we have a lot of more work to do, but one of our thoughts is, if we start from this point and say, these are the pieces of ambiguity, and we know the kinds of difficulties students have, we can start to create problems that have technical ambiguity or discourse or non-technical ambiguity in different ways to help students learn and understand how to deal with problems. So with that, I think we're going to go into the discussion, and Sierra, let us know what we need to do next. I will stop my share.
All right. Thank you both for that really interesting introduction to a brief overview, and clearly there's lots more themes in there that would be interesting to get to access via the full article.
Yeah, and I should point out, so that article, Sierra, you mentioned the full article, that article is currently in review with a journal, and so we'll see. Great.
We won't do breakout rooms due to some technical limitations. I'm just gonna my suggestion is to there we go. So my suggestion is to offer a forum now, an opportunity both for specific questions about this research, or about the expertise that Elliot and David can bring in terms of the problem solving and ambiguity in a larger sense that they've brought, and also thinking about that transfer also to your own context, your own teaching or your own institution. What do you think about incorporating more ambiguity into your assignments for students, or as a greater into engineering education in a broader sense? So thinking about not just this presentation, but also thinking about the interaction with your own context, with your own students and your own teaching to make that relevant. So if you want to put up your hand, your team's hand, then that can make a list, or I think you can also ask questions in the chat if that is more comfortable, whichever one of those. So a question that I had in right from one of the early slides that you presented, David, was the one whose work was it? I think it was Schrader's work that had a small matrix in terms of this is decreasing ambiguity and this is decreasing uncertainty, of defining uncertainty as a lack of information and ambiguity as a lack of understanding about the relationship between things. That doesn't seem to translate at all into the understanding that other students or professionals were, the sense in which they were using the term ambiguity.
Yes, I think from the student's perspective, anything that adds uncertainty is considered to be ambiguity, because they haven't developed that technical expertise of ambiguity. I think, and this is all supposition on my part, Elliot, please correct me, but I think for practicing engineers, they have a pretty good handle on technical ambiguity in their experiences, and I think they're probably less comfortable with the things that surround that technical ambiguity. But with students, I think that not having a correct answer leads them to discomfort, and that discomfort is described as ambiguity. And so, I mean, and I think, part of it, as I mentioned before, if you're teaching a very traditional course where you're using a textbook and everything has a correct answer, which you're calculating, that's not going to give you the practice that you would need with uncertainty and ambiguity that you're going to experience in the workforce. And that's one of the sort of themes that we keep kind of like, coming upon in different elements of the work.
Yeah, let me build on that a little bit. That discomfort was very apparent one of our sub-themes in the non-technical area was the emotional response from students. They had very strong emotional responses to ambiguity, of discomfort, of feeling stress, really. They were stressed. They felt a lot of stress over having to solve ambiguous problems because they didn't know what to do. The other thing that I think one of the differences that you notice, Ciara, between that work and ours is, as far as we can tell, for the most part, I don't know if we found any counterexamples. When other authors have been talking about ambiguity, they're looking at the technical aspects of the problem, right? So they're not, so that's why I think you see, Schrader talking about uncertainty and ambiguity in those having to do with the variables and the relationships between variables, because they're looking at those technical aspects, where what we pulled out is a lot of the other things that also do it. There's a question in the chat. Yeah, Abel, I totally agree, and that's what we're advocating for. So if you look at the chat, yes, we should be progressively developing students' abilities to deal with ambiguous problems, even in a foundational class like statics, right? We can create ambiguous problems in statics that just require the use of statics of concepts so that they can deal with it. If one of the motivations for our work has been, there's quite a bit of work on design problems, right? So capstone design and things like that, and much less on all the problems that the students see throughout their educational experience in engineering, right? And so, one of our arguments has been, if students are habituated to solving algorithmic problems, then it's no wonder they have difficulty when you throw them into a design class and they flounder, they struggle, right? So we need to be doing that earlier. How we do that? Well, that's one of the later stages of our research agenda. I don't know that we have the answers yet.
Let me jump in for a second, Elliot. One of the other issues that I see as a barrier too is that there is a belief that for engineering instruction, you must start with the fundamentals and you cannot move beyond into conceptual land until those fundamental sort of constraints have been attended to. And there's actually pretty good evidence in educational psychology that, yes, fundamentals are important, but actually involving students in conceptual types of problems where there isn't necessarily correct answer and there's ambiguity leads to better learning. But there is this belief, you have to know your times table before you can do the next thing. That is very, very prominent in instruction still, not just in engineering for that matter.
Ina, you have your hand up.
Yes, thank you very much for this presentation. The question before was about how should we prepare, or should we prepare students for ambiguity? And I guess certainly we should, and I think we all agree on that we should. From my experience, I would say that it is important to give them challenges which makes them experience this very discomfort, but at least as important is not to leave them alone with their emotions in that situation, because they might withdraw from the situation, at least internally, if not completely by leaving the course or whatever. But give them the chance to reflect upon it and also to prepare them that this is going to happen. We had a transdisciplinary class created a year ago, which is very challenging for the students, and because first they have to work interdisciplinarily and then transdisciplinarily even, and this creates lots of discomfort and for them lots of uncertainties, and it's about technical solutions actually, but they are social scientists and architects and philosophers and so on. So this is a whole discomfort setting for them. And what we learned is that very in the beginning we have to tell them this will be uncomfortable for you at times, and this is absolutely fine, and we will go through this together, and we will not leave you alone with this, and this is part of the learning process, and in the end you will know much more than you did before. Just take it as a chance. So and then over and over again, every time we feel that someone kind of is overwhelmed by the situation, we will not address this person singularly, but in class we will have a reflection round in the end. And when it comes to teachers, how to prepare teachers for ambiguity, I guess what we did and found very useful, although very challenging as well for us, is to have interdisciplinary teams of teachers as well. Because if you have your own class, it's fine, and you still have your goggles, your disciplinary goggles. But as soon as you've got another discipline there, it gets so much harder, and you experience all those things yourself. And you have to work through it, and then you realize how important this is and how you could kind of rearrange the challenge for the students. I found this very fruitful, although you need a lot of time, capacity, resources to do that. So it's absolutely clear not everyone can do that. But I think it's very much worth trying. So it's
yeah, that's great. I think one of the pieces is when you're dealing with ambiguity and this discomfort, some of the discomfort, I think, comes because they want to get the right answer, right? And you learn so much through failure, and ambiguity, uncertainty, in a sense, requires failure. You're going to fail as you try to move towards a solution. And so one of the things we have to think about is we have to create space for students to fail. And of course, they're not comfortable with that because, they're getting their grades, right? They're concerned about their grade. And if I fail, that means I'm not going to get a good grade. And in some cases, that goes around their self-worth. So I think that's a big part of it. Yeah, you want to say something?
Just want to give others a chance as well. Is someone else there before? Okay, yeah. About failure, that's also something I would like to add something to, because of course our students have been socialized completely in an educational system which is about competition and evaluating them and assessing them and everything. So I'm actually from pedagogies, among others, and from this field we believe this is not a very clever thing to do, but this is how our world works at the moment. And now we have to kind of teach them that failing is fine. And what I worked with for many years now is maker pedagogy. And in the US, you have the great situation that you have all those maker spaces everywhere, and those wonderful equipped ones at the universities. And I don't know about the spirit there in the US, but in Europe, the spirit in maker spaces, which are usually grassroots organizations, rather, is a very value-driven one and an extremely failure-welcoming culture. So what we also try to do over the last years is getting our students into that kind of environment to learn there, to learn that, like with fast or rapid prototyping, that every failure gets you one step closer very quickly to your final result. And we couldn't really reproduce this in university, because when we did it within our own walls, they always had this mindset of, I have to get my grades, I have everything. So, but when we took them out into this place where they saw everyone collaborating so freely and everyone welcoming their ideas, no matter if they worked or not, this helped quite a lot to get them into this different setting. And I always wonder how we get the spirit into the universities. I don't want to take my students forever into makerspaces, grassroots makerspaces somewhere. I would like to do this in our own lecture hall. But it's so hard because this environment already puts them into this mind frame of competition and everything, and not failing, and rather cheating than risking failure. So yeah, probably you have some ideas on that.
Go ahead, Elliot. You want me to
go
have
ahead.
some thoughts? Well, I think, and you're absolutely correct. I think one of the problems with ambiguity in engineering is you cannot make this a high stakes part of a course, right? Because of the nature of essentially how we learn these processes. I mean, students are going to learn to bring a tool set to ambiguity, whether it's model building, problem framing, evaluation, testing, these sorts of things need to be brought to bear. And the idea is that you're wanting to essentially build that tool set. That isn't done well in a formal class. The only thing that I think the students will react poorly, saying, I know there may not be a right answer and I'm being graded on this. So as components of class where it's low risk, then that would be, I think, the best case scenario for trying, at least within a class. But you're right, it's antithetical to how engineering classes are set up and the nature of how they're examined and such. And that's something we're just going to have to try to find ways to work around. Maybe it becomes clubs to start, but this is something where industry is. I mean, some engineers will not start focusing on the workforce until they've had sort of their own internship, so to speak, right? And we want to be able to prepare engineers for the workforce. And where are we with that?
There's an interesting question from Julianne in the chat, saying, from a humanities perspective, we understand ambiguity as the simultaneity of seemingly contradictory perspectives. Do you see a difference between this understanding of ambiguity and technical ambiguity? If you're talking about the theme of technical ambiguity, yeah. So I think we did see this simultaneity of seemingly contradictory perspectives to some extent in the interpersonal ambiguity, when they were talking about how different people might affect the project, different views of what should be done, what shouldn't be done. And so it is, I think, a part of our overall concept of ambiguity, just not in that technical ambiguity piece. It comes into the other pieces. Yeah, so I'll sit there.
I think that for me, the challenge around the system and the system that interface with the students of the system is often around assessment, and then we've prepared them. And I think I often think of myself as a student and my choices, like in choosing to go into physical sciences. Part of that was because of the comfort of that there were right answers, and I didn't like the discomfort of the social sciences where there didn't seem to be right answers. And I certainly wanted to learn right answers, not to learn incomplete things. So I think there's also a selection in terms of where students choose to study and the fields that they're going into, and that then we don't confront them with sufficient discomfort. I got to continue in that comfort of having absolute right answers for quite a long time, which I was very happy with, but wasn't the most productive educational experience for me, perhaps, to not be challenged on that rigidity. And I hear that from students of that their humanities courses, that the way that they're assessed is completely ambiguous, that they're unable to think of any criteria or to fathom the criteria that could say this is a better answer than this answer. And these answers are both completely different, but they're both good answers. And so feeling like what makes an answer good isn't clear. And then having that problem again with the types that continuum that you showed us between algorithmic problems and dilemmas is that there just aren't answers to those dilemmas that matter because everybody disagrees about it.
And we try to you want to respond to that, David? Go ahead.
Yeah, sorry, I'm trying to learn the button still here. I think I'm making a distinction in my head between assessment and evaluation. An assessment can be in an exam in which you're gathering information, you're providing information, where an evaluation it basically connotes a judgment. And so I think with this kind of work, what you need are assessments, but not evaluations. And that may help in terms of differentiating for the students. Like, you're going to have discomfort. This is an assessment, but this is not a formal evaluation. in terms, and you're going to be learning skill sets around these sorts of things. So that distinction helps me a little bit in terms of like, what am I gathering from them and what are we going to be doing with that information? Because most students are like attuned to what is my grade going to be? What is going to be the formal final evaluation of the work that I'm producing?
And what I was going to say was, we attempt to put an objective criteria on these ambiguous assignments by creating rubrics. And I actually don't like rubrics as a concept. I think it puts a veneer of objectivity over something. You know, that you get this many points for this thing, this many points for this thing, this many points for this thing, and you lose the holistic kind of sense of what it is. And, you know, I don't know if you've had this experience, but I've certainly seen cases where, you know, if I go by the rubric, the student gets a high score, but by reading the answer, I know the student does not know what they're talking about. They managed to throw a bunch of stuff down on paper. I'll tell you what I do. So I teach an environmental engineering ethics class, and it's all discussion based. I really don't care about their grades. It's pretty much everybody gets an A, because the whole point is about discussing and learning and getting different perspectives. And that actually helps the students. They say that they come out of there with like these new perspectives and understandings. What I do for the major assignment is they have to write a paper. They pick an environmental engineering issue and write a paper analyzing the ethical aspects of it. And I give them sort of the pieces to write about. But what I do, again, to help support them is there's several assignments along the way. They have to sort of write an outline, which I look at, and it's graded for participation by turning it in. I give them comments to help them improve it, but that's not graded. And then it gets to the point where they submit a draft paper. Again, that's graded just based on the fact that they turned it in. And I mark up all the papers with comments and stuff. And it's only the final version, after they've gotten all this feedback from me, that is officially graded. So it gives them a chance to learn and to get things wrong, to fail as they're going along. That's one way that I've come up with to deal with that and help them.
Ina, do you have something very short?
Yeah, I just exactly to what Elliot just said. I wonder. I mean, I love your approach, but I wonder, do they put a lot of effort into the first and the second assignment?
They do. Well, most of them do. Yes. Yes. I certainly get papers that don't need much more work, and then some that do need a lot of work. But I don't think it's because they didn't try. It's because they didn't really understand. You know, they're not as good at that kind of writing as others.
So what Elliot's describing from an educational standpoint is referred to as basically mastery learning. It's more difficult to do in the classroom, or at least to better learning. But what we want to do is use sort of mastery learning to then get them to a place where, you know, goal and performance that happens in the engineering workplace would be achieved. So, yeah.
All right, I'm gonna just jump in here and just do a little bit of a wrap up, and then I don't need to rush away. Maybe Elliot and David can also stay around. So if people have some lingering questions that they want to discuss, that we'll have an opportunity to share those. So I just wanted to do a little introduction for the next month's webinar, which will be the second in the series, which will be with Ina, who's here with us. And she will be discussing, I think, more about the course that she mentioned briefly today, about using irritation as a didactic principle in terms of getting students to engage more with ethics and develop their competency around that. I've planned for about 6 webinars. I'm trying to nail down specific dates for my guests for 3 and 4, but look in the SEFI newsletters and other information for those specifics, as they will be arriving soon. And what I'm interested in sort of doing this little exploration of different types of uncertainty, as we saw from the chat today. And then perhaps in a second phase, thinking about if there are any opportunities of people working on similar things or in similar context to perhaps do some either some coordinated or collaborative pieces there, and then working towards some sort of collaborative communication format, and that will all be get to defined in a future moment in terms of, so there's no commitment. You can come to the webinars and that's it. But if these are topics that are really interesting to you, to take this opportunity to connect with other people who are interested in these topics or working on these pieces through these upcoming webinars. So it was a pleasure to have you here today. As being respecting my typically Swiss location, I want to make sure that we do end on time. And so Elliot and David, thank you so much for accepting the invitation here and for the really interesting presentation that you provided us with, providing both an exploration of uncertainty and an ambiguity, and that complementary approaches in terms of perspectives of both student and the professional's perspective. So I'm interested in getting to dig more into the details of that when that article clears peer review, where that is. So thank you again for joining us today, and I hope to see many of you in the upcoming webinars.